Hello learners, welcome back to Education Program Online. I'm Teacher Christine, taking you in mathematics for Senior 3 and Senior 4. So we are still continuing with what we call application of differentiation. We are moving to the second part of application of differentiation. The first one we had, it was on stationary point. So the second one we say it is part B, application part B, that is equation of a tangent to a curve. Equation of a tangent to a curve. Equation of a tangent to a curve. So this is what we are going to look at. Equation of a tangent to a curve. Equation is not a new word. Equation simply means asking statement, finding something which has no answer or which has unknown answer. Then we have a tangent. A tangent simply means a point of contact or a point of touch. And then if we are asked to find equation of a tangent, then we had to look at the following examples. So we say a tangent is a point of contact. So let us go straight to our examples on how do we write equation of a tangent. Example number 1, the question said find the gradient of a tangent. The gradient of a tangent and a nominal to a curve. And a nominal to a curve. Of a function y equals to x cubed minus 3x square plus 5 Learners, I want you to look at the chalkboard. We have the word gradient of a tangent and then a nominal to the curve. So when we look at what we call the gradient of a tangent, we know what a gradient is, and we have known what a tangent is. And then we want to see what is a nominal. A nominal simply is that line that cuts a circle, or a line that cuts another line perpendicular. So that is what we call a nominal line. So what happened here, if we are asked to find the gradient of a function like this, then you need to apply the first, we know, apply the formula of a gradient in differentiation, that is the dy over dx. So what do? You say dy over dx equals to what? Equals to n x raised to n minus n a x raised to n minus 1, and then plus the 0, because this is a constant. And then when we substitute, we get 3 1 times x. 3 times 1, we get the power is 3 times x, we get x raised to 3 minus 1 minus 2 times 3 x times x raised to 2 minus 1. So we find that our answer will be 3x square minus 6x. So 3x minus 6x. So now for us to find the gradient of this, then the question must have given us the points. But in this case, the points are not given. So you'll simply say x at 1 point this. So the gradient of a tangent at this point will be 1, 3, and then now you substitute. You come to look at your points here, the given points, which is 1 and 3. So this is for x and this is for y. So after differentiating, you have to substitute the value of x with the given points so that you can get now the gradient. Then now you come and say the gradient, we abbreviate it as m, equals to 6 times equals to 3 times 1 square, because x is 1. 3 times 1 square minus 6 times 1. That one, we got it from the given points here. Then now we say we have 1 square will give us 1 times 3, we get 3 minus 6. So the gradient equals to negative 3. Then now you come and say, therefore, the gradient of a tangent which is m equals to negative 3. And then we also come and find the gradient of the nominal. So the gradient of a nominal, is given as 1 over negative m. 1 over negative m. So this is the formula of finding the gradient of a nominal. And therefore, we have known what the value of m is. We simply substitute. We say 1 is 1 out of what? M, which is negative 3. So we shall have negative and negative 3, which will give us 1 over 3. So that is the gradient of a nominal. And then now we look at the example number 2. In case you are asked to find the gradient of a tangent, that is what you are supposed to do. You'll simply have to differentiate. After differentiating, you substitute the value of x in the results that you have got to get what we call the gradient. And once you have got the gradient, it becomes easy for you to get the gradient of a nominal. Remember, we said a nominal is that line which is a perpendicular. It is a perpendicular line. And then we look at example 2. Example 2, they say find the equation, find the equation of a tangent to the curve, equation of a tangent to the curve. Y equals to x squared minus 5x plus 6 at point 1, 0. At point 1, 0. So if we are now asked to find the equation of a tangent, you cannot find the equation of a tangent unless you know the gradient. So what do? You first find the gradient of a tangent before you get the equation of a tangent. So we say solution, you get it, dy over dx, of this function. So when we differentiate this, we simply get 2x minus what? Minus 5. So after getting this, then we now get what we call the gradient. So we come and say, therefore, the gradient, which is m, equals to 2x minus 5. At which point? At point 1, 0. So we substitute the point x with 1. So we have 2 times 1 minus 5. So which will give us 2 minus 5. So our gradient will now be negative 3. So our gradient is negative 3. So after getting the gradient, then we can now be able to write the equation. And our equation of a tangent is the same as the formula of equation of a straight line. So now you come and say equation of a tangent. Equation of a tangent is given as y minus y1 equals to m into x minus x1 at 1, 0. So that is our points that we are going to substitute. So now this is the formula for equation of a tangent. Equation of a tangent, y minus y1 equals to m into x minus x1. So we come to our given equation here. We find that here they have given us x and they have given us y. So we take this as y1, x1 and then y1. We simply say this is our x1 and then this is our y1. So when we come to our formula, we substitute. We don't know the y. We have y minus y1, which is 0, equals to m. Our m is given as negative 3 into what? Into x minus what? Minus x1, which is 1. So this will give us y equals to negative 3x plus 1. So that is our equation of a tangent. Equation of a tangent. Or we can simply say Therefore, equation of a tangent will now be, we can transfer the other side of our right side to the left side. Then it will be y. When negative crosses here, it becomes positive 3x and then minus 1. So equals to what? Equals to 0. So this is our equation of a tangent. And then we look at example number 3. Example number 3. Example number 3 says, write the equation of a tangent. Find the equation of a tangent to the curve. Find the equation number 3. Find the equation to the tangent. Find the equation of a tangent. Equation of a tangent to the curve. To the curve. Find the equation of a tangent to the curve at a point where the curve cuts the x-axis. Y equals to x squared minus 5x plus 6 at a point, at the point, a point where the curve cuts the x-axis, where the curve cuts the x-axis. The x-axis. So we say solution. What happened here? They have given us the equation, and they have not given us the points that we can substitute, because we said for us to write the equation, we must know the gradient. And now in this case, they have not given us the points. So, but there is the word cut here. The word cut means intercept. So, if y intercepts x, then x is at 0. And when x intercepts y, then y is at 0. So you simply say y intercepts the curve, occurs, intercept the curve, occurs when x equals to 0. Then you simply do what? You simply come and say, if x equals to 0, then y will be what? Y, which is x squared minus 5x plus 6, will now be 0 squared minus 5 times 0 plus 6. So this will give us 6. So meaning that our points now here will be x, y, and our x is equals to 0 and y is 6. So what do? You have to first find the points before you write the equation of a tangent. Now after knowing the points, then now you can come and find the gradient. Then now you come and say, therefore the y over the x equals to 2x minus 5 at which point 2x minus 5. Therefore, the gradient here will be m equals to 2x minus 5 at the point 0, 6. At the point 0, 6. Then now we substitute the value of x, which will be 2 times 0 minus 5. So the gradient will be positive 5. So after getting the gradient, then it becomes easy for you now to write the equation of a tangent. So our equation of a tangent will be y minus y1 equals to m into x minus x1 at which points? Our points here is 0 and 6. 0 and 6. So what do? You are to substitute now our equation formula, which will be y minus y1 will be 6 equals to our m, which is 5, into x minus 0. So this will be y minus 6 equals to 5x minus 0. So 5x, we can now form our equation, which will be y minus 6 equals to 5 x minus 6. So we can either take this to the other side or we bring 5x this way. So we simply now say, therefore, equation of a tangent will now be 5x minus y plus 6, because this one will cross the other side, will come to the other side, and also y will cross equal sides and becomes negative, equals to 0. So learners, you have seen the two different examples or ways of writing equation of a tangent. Writing equation of a tangent when the given points are there, and then writing the equation of a tangent when the given points are not there. And then lastly but least, we can look at number the next example, which is number 4. It says, example number 4 says, find the equation of find the points at which the tangent to the curve y equals to 2x cubed minus 3x square minus 1 is parallel to the x-axis, So look at example number 4. Example number 4, they are asking us to find the points, in this case, the points at which the tangent is parallel to the x-axis. So what do? We simply how to analyze the question. How do I get into the points? I have to differentiate the question, the function given. So your first solution in this case, you say it is dy over dx. So when we differentiate the given function, we say 3 times 2 will give us 6. So we'll get 6. And then 3 minus 1, we get 2. And then we have minus 2 times 3, we get 6. And then x, 6 times x, we get 6x. And then power 1. And since this one is a constant, is given as 0. So after your differentiation, you will now look at the outcome. And then it reminds us the lesson of yesterday or the previous lesson. When after differentiating, we look at the coefficient of x. Can they be divisible? Yes, we can divide them by 6. We say we can have 6, reduce it by 6, which will give us minus 6x over 6. So that this will go, and then we remain with the x square, and then this will cancel, and you remain with the x. Now in this case, we find that we have got the quadratic equation. So since it is a quadratic equation, it will require us to factorize. So when we factorize this, we get x into x into x minus 1. So that when we open the bracket, x times x gives us x square, x times negative 1 gives us negative x. So, and then now from there we can now get the values of x. So we simply say we have x equals to 0, or x minus 1 equals to 0, which will give us x minus 1 plus 1 equals to 0 plus 1. So our answer is 1. So the values of x, we have x equals to 0 or x equals to 1. So after getting those values, then we can do what? We can substitute our function y. So we simply say if x equals to 0, and then y, which is 2x raised to 3 minus 3x square minus 1. So we shall have 2 times 0 cube minus 3 times 0 square minus 1. So this will give us 0 minus 0 minus 1. So the answer will be negative 1. So our answer will remain as negative 1. And then now we say, what about if x equals to 1? So if x equals to 1, what will happen to your y? So we also substitute it in value in the function y to get the value of y. So we say y, which is given as 2x, will now be 2 into 1 cube minus 3 into 1 square minus 1. So this will give us 2 minus 3 minus 1. So minus this, we get 2 minus 4. So our answer here will give us negative 2. So you find that the points, the 2 points that we have been looking for will be x, which is 0, and then negative 1, and which is 1, and then negative 2. So those are our 2 points. So with this, my dear learners, I hope you have followed up these examples very well, and I think we have come to the end of our lesson for today, and I'm giving you just 2 questions as your homework exercise. So you write this as your homework exercise. Your homework exercise number 1 says find the equation of a tangent. Find the equation of a tangent. Find the equation of a tangent to the curve. Of a tangent to the curve. To the curve y equals to x squared minus 3x minus 4 at 3 negative 4. And then 2, find the equation of a tangent to the curve y equals to x cubed minus 1 x squared plus 1 at x equals to 3. So go and write this on your books, and then you go and try them during your free time. With this, we have come to the end of our lesson today, and I wish you the good day.